think he hears it. All right. This was planned like a rehash of what we already learned so far, and it's kind of Smurf. Not too fast. Smurf game. You maybe know that one on Sesame Street. That's just the guy who likes the count. That's why he is the count. Yeah, and because the game is just called how many elements this list had. Yeah.
Round one.
Any guesses? That's easy. We're just starting very easy. What?
4.
Yeah, of course. 4. How much now?
4.
Yeah. You're right, yes. Now? What?
3.
3 should be flattening.
3, 4. Any other?
I think it's good 4.
Maybe 3, 4, 4.
Yeah. Quantum superposition, yeah.
Any 3, 4.
No. It's 4 because they just do grouping, but in array context it all flattens out. You know, because that is not a function call, you know, and that's why the bracelets doesn't matter, and we also don't assign to a scalar. We have where we have to group. Yeah, it's really the comma that generates the list. And of course, the braces say, okay, we want to have this here as parcel, but the parcel in array context flattens out again. So I left just array. So now. Hey, yeah.
3. I had to retry.
Also 3, yeah.
Good. I retry.
Okay. Do I get a 4? Of course you're right. You know your Perl 5, and that's not the difference here. Maybe let the noise out. Yes, of course, that are 3 elements. I don't have to explain you. That's an array ref. Also, there are no references, but it's an array object. One item in that list. So it has 3 elements: the 1, the array, and the 3rd element is the 4. Right. How many elements is in number?
No, it's really called 1.
Can I get something else than 1? 1. I was planning to buy sweets, but there were so many sweets on the list, so I wanted like for every the right answer, or at least someone got the whole block right. But all right, I dropped that idea. No, yes, it is 1. Of course, it is. It is 1. It's 1 array object, and it's in the first element of array. You're so far right. So you see, it's not that much surprises when you're coming from Perl 5. Yeah. And like last goodie. Sorry. No, I thought you wanted. So I have here a function call, and like I said, $@ underscore is still around. How much elements he gets when I have this function call? Ha! Now it gets tricky.
What kind of signature does the sub?
What?
What kind of signature does the sub have?
No, it doesn't matter. Without at underscore is only populated when it has no signature at all.
Okay.
That's the rules here. 4, all right. And your logic behind? What's your reasoning?
Because no, I think
Braces?
the bracket is not.
Doesn't care. They doesn't
Yes.
care about the brackets.
So we have.
That's actually smart, but not quite right. because it's our 5 elements. Because the thing is just in this context, it just flattens out. The one thing you didn't know, that this array gets flattened out, because that really forces flattening. But other than that, you're completely right. Yes. Yeah, that's also one of the things good to know when I start to program in Perl 6. Yeah, because it's already there. Just go to Rakulu. I even recommend the new nom branch. It's really just to get into. It's all really there. You just have to type up the 3-4 instruction. If you have installed Git and install Perl and C compiler, then I think when you use Linux, you have that. If you use Windows, you should have that too. Good. Round 2. Not bad so far, but as you may think, it gets more complicated now. So, start your brains. How many elements?
4.
Remember what I said? I talked about that in the first part.
It's a set.
What?
It was a set.
No. Sets. There are no sets here. No. Of course, that is a list. But from that, because that's a list generating operator. But from that list, dollar number, because dollar number is a scalar, just gets to 1. That's all. Yeah, it's what I showed.
The first.
Like when I do really, let me go back in history, all the things I showed. Oh,
It's getting confused.
yeah, it was too much for him. All right, here it's slowly going. Here's what I showed here.
Yeah.
That's the idea. Yeah, it's for that. So the first scalar gets the first, the second gets the second, and that's all. So yeah. The next version of this is called the Rolls Royce of things, but that's still a Beetle. Yeah, that was I think it's most what you know. All right. So we've done this. So of course, one element. Now, how many? Easy, huh? Or? You think still one element? No.
Maybe.
Because no. Actually, one is right. There is in the object. What goes here is like I said, a parcel. But you can treat the parcel as an array. So you think you have an array with 4 elements. So it's basically on the operational level what you have, an array with 4 elements. It's not quite a list what you have. I sort of started to explain what are the difference between parcel. You were there? When I explained the difference between parcel and list and array. But we will get into that again. What?
I missed it.
Yeah, I know that you, but I thought he. Right. How many elements? Remember, we are not in. Before it was easy because before we had a list context. Now we have scalar context, so the braces behave differently.
You still get the number 1.
What?
You still get the number 1. Because the parcel is the second element. in
Oh,
the
of
order.
course, of course. And now?
Now you get the parcel.
What? 1 or 2? Okay. And what?
1 and 2. She said the first 2 elements. She said 1 and 2.
Yes. Sorry, I misunderstood you. My mistake. Of course, you get this parcel into, and you can treat it as one array. Yes, very good. Oh, sorry.
Yeah,
This,
about-
I was that one. Yeah. Okay. And of course there are 3 elements. Yeah, because that is one element, and we get that parcel with 3 elements. But the last one is a little bit tricky. One element?
No?
What?
One element.
The, no. We finally get an array.
Yes. And that array goes into number. And that array has 4 elements.
Finally.
Yes! You understood it.
This
The
is
square,
only
the
one that-
square brackets generate an array. And that array goes into the scalar. So the scalar is array with 4 elements.
This is the only one that actually makes sense.
The other one not. So blame Larry.
Yes. I usually do.
Alright. Yeah. Round 3, the last one. But you're not that. I expected worse. So in this round it's about evaluation. We have 2 lists, and with that content, also P means just the numbers of P, yeah, so PD, to make it short and sweet. And they both have the same content, yeah, but this one is a scalar, this other is a list. All right. How many elements has add numbers? Maybe
I
3.
would hope 3,
You hope 3.
but I don't remember how much it flattens.
Maybe also 6.
Yeah, it depends how much it flattens.
Yes, of course it flattens.
This one doesn't.
It's
Not so,
What?
of course. Not so, of course.
Yes?
No, no, no.
All right. Yeah. Can you come? So,
Quando passiamo agli hash,
All right.
così complicato.
Wow.
The previous one,
yes.
is it like a push
What?
1, PD and 4? Is it like a push?
I don't get it.
What?
What? Yeah, but if,
Push me.
yeah, but why
Does
should
it
it?
work?
It's just a list, and it gets evaluated in the list context, so you get a flat list. Where the push come in? I don't get it. PD, at PD doesn't get manipulated in any way. It just stays there.
Okay.
Yeah. So, yeah, the big question now is, of course, if $PD gets flattened or not. Yeah, that is the question.
3.
What?
For me, it's 3.
For you, 3. Yeah. What? Of course. Because that's just object. Also it's this emulates a little bit behavior of Perl 5 and also throwing lists together and play with them. And that's really just like dollar explained. It's one item. It's one single object and it's treated that way. That what you see here makes the action. So that's actually almost this. Oh, I forgot the comma here, but we think you're pretending that here's a comma. There are over 200 slides. Yeah, and that's some mistakes. Yeah, we maybe don't come to everything. But you said it's 3. Yeah, of course, because this method forces the item context, and there are 3. And of course, yeah, I let the surprise out. If I force the list context, even when it's dollar, yeah, I get the flat list. Then the bonus, I have array with 3 times nil. How much elements has this array? That's a tricky one. Any guesses? Some. What?
Yeah.
Yes, that's true. If you give it in a Boolean context, which tests if it has any content, you still get false, because it has no content at all. Because 3 times nothing is still nothing, boys and girls. Yes. All right. Yeah, that was the point where I want to throw cookies around us. But we have plenty of cookies already. So of course, if you take such examples, we don't have to guess, because in such example it clearly states there how much elements it has. This is Perl 5. In Perl 6 we would write it in this way to have a clear distinction. Yeah, because of course the list can be scalars, arrays, and we have all kind of context to be really clear. We have the single x in Perl 6 just produces strings, makes multiplications string-wise, and like it does also in Perl 5. Like I said in previous talk, this is always Perl 5 and this is always Perl 6 to give you comparison when it's that form. And when I want to have this like in Perl 5, then that still, when I do the braces around, I still get a string, because that always makes string multiplication. Yeah, and if I want a list, I use a double x. Yeah, that makes the thing much more clear. Yeah, if I have here a string and the string gets multiplied, it's just only Perl 6. And if then I have a list, then and I use a single x, the list just gets treated as a string, because this just multiplies strings. But of course, when I use the double x, then I get a list. Yeah, comment. Okay. No. I don't see why here's a difference between that two. What I was thinking? No, I don't know. I think I want to compare that with Perl 5, because in Perl 5, when there are round braces, then and have a single x, then would you get the same result, of course. All right, the range op. We all know and love that, yeah, and long time loved about the silly Java programmers who had to write this for style loop, and we just make 0.9 to get our nice arrays. That is, of course, still around in Perl 6, and of course you don't have to use the round braces, except in corner cases when you needed it to separate and to clear up disambiguations. You could also write it in Perl 6 this way, because this Dach, what's called in English? Carrot? Carrot. This means except. If you have a range, but except of the border. It's also, if you don't put your ranges in the list context, they are still range objects. Even in a scalar context, they are not immediately evaluated, so you can maybe a range that says, give me the numbers between 0 and 10, but not 10. And if you make a smart match, again, 9.999999, it still gets true, because it's not 10 and inside the range. So you can exactly express what mathematicians think, and don't have to do some screwy things here. Yeah, because this really expands to that. Yeah, that's the same. And of course, you could write it also this way. Because when you put it into a list, it now gets also to 0, 9. Because -1 is excluded. Yeah. The only thing is, you have to get sure that here is no space in between. That's one operator. You know, that's one. You can. Come, welcome. you surely seen on the internet the strange smileys who look like that. Yeah, and that's one operator. Yeah, that's like it's combined between them, but if you make spaces here, it's no longer working. Yeah, it would not be express the same thing. So I think it looks a little bit like dot, if you know what I mean. Miyazaki is cool. So of course, you see what I changed? Yes, 3. It is the sequence operator. News. One of the great cool features were invented last year. One of the biggest changes now in Perl 6 is the sequence operator. Of course, this one still produces the same as 0.9. Yeah, you know that, yeah. That no changes so far, but the sequence operator can do much more. The sequence operator is basically Larry's answer to the long and good question how we do for loops if you want to skip inside patterns. Yeah, if you want to, there are languages where you say I want to loop from 3 to 12 but skip every second number and such. And for problems like this, this is our grand solution which we reuse everywhere. So, like I said, this is a linear sequence. And this is the solution. What I said, you make 1,3 and dot 9. So you get you say how you want it, and he makes that up to 9. And that's how it's written. A sequence is written. Which is, I think, clearly readable than when you have to parse before the step, and yeah, it is clear. Or would anyone disagree? I think it's pretty obvious what it means. Yeah. Good. And you can also have geometric. Then you have to, of course, add one element more, so that Perl recognizes, oh, it's no longer linear sequence, it's a geometric one, and he does the rest. Pretty handy. But, you know, Larry, the power doesn't stop here. It's, to be serious, it just begins. Actually, that is a Fibonacci. How cool is that? Here we have the whatever, but in this case, it gives you the elements it actually has. It should be also work on auto-generated variable names, but this doesn't work on current norm. I tested it, but this works on current norm. You give him these two elements. Here, Gauss enclosure means a block in it. If it's short, you can leave it out, the curly brackets, but it's still a closure. And of course you want to do a plus, and here at the stars gets filled in the element he has. Still, always, because there are two stars, the last two elements get into it. And so plus, you add your way up the Fibonacci sequence, you surely know. And even if you want to multiply, it looks silly when you say multiply, but it still works. Yeah, it's one of the areas where I try to convince Larry that there may be some ways you can optimize. But you see, that's really his power. You can get any sequences of any kind. Yeah, that's I love it. All right. There's only one problem with that. You really have to hit the limit. If you don't hit the limit, like in this case, yeah, of course you have only the odd, and 10, of course, as you know, isn't odd. It's the same. That is actually the same thing as when you would write it this way. He's missing a dot. It's not. It shouldn't be not a comma but a dot. Our mistake. But here, in that context, star means infinite. Yeah, it's the same as saying this. It's an infinite list. Yeah. So you have really be careful that to set your limit right. And what's even worse, in the moment, oh no, that's you even that doesn't give an error in Perl 5. You would get an error in Perl 6. If you give an infinite list, you said, okay, we have an infinite list, no problem so far, because there's just stored an object. Yes.
It's like the lazy valuation.
That's the laziest thing, yeah. Because arrays in Perl 6 just have two parts. They have a storage for the element, and they have an iterator. And if you want, so give me the first, then of course, then give you that. And so give me the fifth element, then use the iterator and produce up to the fifth element, just in the moment you want it. It's like in Haskell on the functional programming languages. So, so you have still no problem with this infinite list. Just when you say, give me the whole list, then you start to get a problem. Yeah? So lots of waitings, or if you want to print, if you want to put out that, you get lots of numbers and can't wait. Or of course, if you want the length of the array, you have also need some patience. Yeah. So if you put that in a scalar, you still have a range object. Just if you evaluate it to a list, then you get an array. And that's because an array is a storage room for scalar items. A list is just values. There's a difference. All right. Because I have almost no time, and what? Yeah, I'm sorry too. So. Of course, if you put this infinite list in a scalar, of course you have the 0 because it's the first element, yeah, but we learned already that. All right, let's skip. I said this. The reify is a method to generate new ones. You can also call that if you want. It's like the API. And like the Perl method I already showed you in the first part, if you call that, you get this. Because if you call reify, he generates the first element, and that is like the range for the rest, how to generate that. All right, you know these, yeah? No explanation needed. Just one comment on reverse. Because we have the objects, we need now to distinguish the reverse in the scalar context and the reverse in the list context, and that's why we have actually three different words for it. We have in the scalar context, we have flip, to flip aside the word, the order of the letters. In the list context, we have reverse, to reverse the order. And if you have a hash and you want to inverse key value pairs, you have invert. And if several keys show to the same value, you get arrays. There are still some it's not exactly, and it's not allowed implementation, but no time. What I want to show you were just hashes, but they're still like in Perl 5. You can omit the braces, but you see what is a hash. But we have even different syntax, because also that's the syntax of the, in the signature for the named parameters, because the named parameters are just pairs. Yeah, of course, you know, you remember the angle brackets from the start? Here are the angle brackets again, and they do the same. They're just quoting. Yeah? So you can spare characters. So here, of course, you get a pair because it's a list, and just the first element of the list goes in the scalar, like we know already, and that is this one pair. We have now pair object. Yeah, you like to see. If you have braces, that is a parser. And if, like I said in the first part, and actually when I print out that parcel, I get, it looks like this, because it still takes hold of the positions, and because that are pairs in the position. Just when I put it in the hash context, I get a hash, but I could it also assign to a list, and then I got a list of pairs, and that's why I need the order still. Yeah. Was it a question? this is okay. You can force the hash context this way, or this way. It's like I said showed in the first part. And you one single value out of a hash you get, of course, this way. It is a method call, or you can, of course, do it this way, or with every relation that way, like already explained. You can, of course, get several items, invariant sigil. Nice methods. You have, of course, the keys. You can before the hash as call C, but you have also the keys method. Where you can Verdi, Puccini, and so on, all the values. You get the operas, then the name, and key value is just a flat list of key value, key value. This works on arrays too. Also arrays have the keys, values, and key method. And if you have a single pair, you just I was missing one slide. It was once upon a time there was a slide. All right. Now, what I wanted to show you, you have also on single pairs, you have these also. You have a key method and a value method on a single. If you had a pair and it's scalar, give me key, give me a value. Okay, that is gone. Sorry. Okay, so you have if you take on hash the pair method, you get a list of pairs out of it. If you, of course, you can still ask if there some key exists. But you can just ask about one element at a time. Also delete just one element at a time. Yeah, these contexts work still, like I said, on list. This proves it is, if there are any pairs in it, the number of pairs, or just the string content, key value. The only difference to the list is in the hash you have between key and value a tab. So you can separate this if you make parsing of that and so on. Yeah, can come in. So the invert I already told about. What's really cool is a classify. It's a sort of map you can do on lists, and you can put every value of that list in a category and produce a hash. And also the categorize. The difference to the categorize is you can put a value in several categories or in no category if you return a nil. Yeah. So it's also for functional style programming, and it's very efficient. I love it. Yeah. That. Yes. Okay. If you have I just run. It's I don't make touch. What?
He comes after you. You are doing it.
I thought no.
Carry on.
If you have a Schwarz transform, you can write it in this way or in that way. On that way, that's your pipes. If you make it visual distinctive. And what I wanted to show are meta-ups. You know these meta-ups because equal sign, yeah, from Perl 5. And these are the meta-ups for lists. Yeah, that was the called hyper operator if you want it on the list. That just checks the length. If you do that, if this is the important side, then it does the length. If you did it this way, it takes the length from here. And if you do it this way, he checks the lengths of both sides, and if it doesn't match, it doesn't error. Yeah. It also works on nested. I just fly over that. It has to also be into the depth, be just correct. This is not correct because you're here on those are 5. Yeah. Then you have really nice reduce. Yeah. That would be equivalent. And when you write it this way, you can have a single true if all these numbers are all right. Then there was a triangle. That means you get 1 and 1 plus. So I just keep that as a cross if you want combinations of that. And that are meta-ops. They are just combination, and if you put another operator after it, then you do something with the pairs. Yeah? And it's also with a zip. You can just zip like you know it, the lists, or you can zip with adding each pair. Yeah? Or use sequence. The sequence method is just the same as the S operator. Because all the meta-ops I showed, they do implicit parallelization. If you have several core, they do the work of spreading it to the cores. But if you say, I don't want it, you can force it with the S meta-op. It just has to run on this one core, or with the sequence method. No? Huh? All right. And no, and is written this way. And this, they are doing the hard work. I was just here for the fun stuff. All right. Thank you.
We've never managed to leave this talk in its entirety at a sensible pace. You just have too much stuff to say.
Yeah. Any question, or you're beaten up by the concept? What?